Today we'll go over all about Ethers.js, what it is, and how to utilize it to write scripts to interact with the blockchain. So before we get our hands dirty with Ethers.js, let's understand what it is and what is the problem that it's trying to solve. So to do that, let's first have a look at the website architecture of Web 2.0. So let's say you're watching this video on your phone, on your desktop. You're watching it from a browser, and the web browser is talking to something called the front end. So the front end just basically displays like the layout, the design of the entire website. It's just basically what you see on the website, and it's usually programmed in HTML, CSS, and JavaScript. And this front end talks to a backend, and the backend is just basically like a central server where all the code is stored in, maybe the APIs, which is talking to like a different front end, or there's like a database for all the user information. So basically the browser talks to the front end and the front end talks to the back end. The back end gives the front end some functionality, and the front end is going to be displayed on the browser. So this is typically the architecture of a Web 2.0 application, otherwise known as a website. The architecture for Web 3.0 application. So Web 3.0 websites are usually decentralized applications, like for example Uniswap or PancakeSwap. So in Web 3.0, the architecture is actually pretty similar to Web 2.0. You have your browser and it's talking to a front end where you're interacting with the decentralized application, the dApp. It's also programmed in HTML, CSS, JavaScript, but for the backend, instead of having all the code, the API, the data stored on a central server, it's stored on the blockchain. So all of the data is stored on the blockchain, and the smart contracts is giving the front end some functionality. So that's how the front end is talking to the back end, and the back end is basically giving the functionality to the front end, and the front end is helping the browser to display its interface for like a decentralized application or something like that. So if you want to do something like this, then a critical part to understand is how do you make the front end and the back end interact? How can the front end talk to the back end? So basically the front end needs to be able to read information on the blockchain, and it has to be able to write information onto the blockchain. So let's have a look at how exactly we can do that. So over here, basically, we have a blockchain, and basically a blockchain is a peer-to-peer network of nodes, basically computers that are allowed to talk to each other without the need for any central authority. And each node basically stores a copy of the blockchain. So each of these nodes have an individual copy of the entire ledger of the blockchain. So let's say you want to create some kind of dApp, a website that wants to harness the full power of the blockchain. You want to create like a website that, for example, like signs a transaction or interacts with some of the smart contracts on the blockchain. So how do you do that? You can do that through a web browser, you can do that through when you write a script, or you can do that through a backend server. So the way to do that is that that's what basically the client does. And the way to do that is that you need to connect the client to one of these nodes so you can harness the full power of the blockchain. And this connection allows you to interact with the other nodes of the blockchain and basically interact with the smart contracts, do whatever you want to get the full power of the blockchain. Because remember, each node has an individual copy of the entire blockchain. And that is exactly what Ethers.js does. Ethers.js allows to connect your dApp to one of those nodes on the blockchain. And with Ethers.js, you can write JavaScript scripts that allow you to, for example, sign a transaction, program like a trading bot, do an NFT minting site, etc. So Ethers.js allows you to harness the power of the blockchain by writing a JavaScript script and importing Ethers.js to connect to the nodes on the blockchain, and you can build all sorts of cool stuff using the power of the blockchain from Ethers.js. So now that you know what Ethers.js is and the problem that it solves and the use cases of it, let's jump right in and write a script using Ethers.js. We're going to write a script that sends a transaction on the blockchain. So basically this script will send a certain amount of ETH from one wallet address to another wallet address, and we are going to be doing this on a testnet, on a testnet called Gorelli on Ethereum. The reason why we're going to do this on a testnet is because if we do a transaction, if we write a script that does a transaction on the mainnet, we have to pay actual money in order to complete a transaction. That's the gas fee. And we don't want to be paying actual money, we just want to get some fake ether. So later what we're going to do is to go to a faucet and get some free ETH, free Gorelli ETH. But for now, let's jump right into this project and let's learn how to basically use Ethers.js to write a script that sends a signed transaction on the blockchain. So first thing, before we can use Ethers.js in our JavaScript program, we have to basically import it. So the way to import Ethers.js is pretty simple. It's just require bracket ethers, and there's a semicolon at the end, and we want to assign this to a variable. So that's all we do. We just do const ethers, const ethers, and then equals. That's all you gotta do. So basically this line helps to import Ethers.js into our project, and congrats, we have Ethers.js imported into our project. Got Ethers.js put into our JavaScript file. How do you actually make it so that our script can talk to the nodes on the blockchain? Basically what I talked about just now, having our script interact with the node so we can harness the full power of the blockchain. How do you do that? So as you can see, we need to connect to one of the nodes, but we're not going to set up our own node because first of all, it's time consuming, you need a lot of space, and it's just not worth it just for a hackathon or learning some blockchain development. So how do we connect it? How do we connect our script to the node if we don't want to set up our own node? We'll just use someone else's node. So to do that, to use someone else's node to connect to the other nodes, all you need to do is to go to infura.io, and then we have to, infura.io is just basically provides this kind of service for us. We have to log in. I'm already logged in, but basically we have to log in and click create new project, and then select Ethereum. Project name, I'll just call this sign transaction, and then let's create. Let's load, and you will be led to this page. As you can see, Infura has provided us an endpoint, and this endpoint is basically allows us to connect to the other nodes of the blockchain. And keep this page open because we'll have to use this endpoint soon. But let me do some explanation first. Basically, Infura is a blockchain node provider, as I mentioned a lot of times already, that allows you to connect to the other nodes on the blockchain. So as I said, we need to keep this thing, but basically we have everything. How does this all work? So basically in like a web 2.0 architecture, to connect like a client to like the to connect from the front end to the back end, basically this arrow is just like the HTTPS. This is the protocol which is giving the secure connection from the front end to the back end. Web 2.0 uses the HTTPS that you see in many websites. So, but for Web 3, this HTTPS is basically called a JSON RPC provider. So a JSON RPC provider is basically allowing us to giving us a secure protocol connection from the script to the blockchain node. And Infura provides this with this API endpoint that it gives us. And Ethers.js also allows us to do this JSON RPC provider you see in the documentation. I also advise you to read the documentation as well. They have a section called JSON RPC provider, and as you can see, JSON RPC provider is a popular method for interacting with Ethereum, with the Ethereum nodes. That's what I said just now, and it's available in all major Ethereum node implementations, blah blah blah. So this is sort of like a standard for connecting to the nodes in a blockchain. One thing that I forgot is that you have to actually change this endpoint from mainnet to the Goroli testnet. As you can see, when you click mainnet, they give you like the mainnet and a bunch of testnets. Because we are going to develop our script onto the Goroli testnet, we're gonna have to choose Goroli, and then later you have to copy this endpoint. But just basically keep this endpoint here and keep this page over here. Now that we got our JSON RPC that we could use to connect to the nodes of the blockchain and harness the full power of the blockchain, let's do that exactly for a script, so our script can interact with the blockchain. So to do that, we just need to type ethers.providers.json RPC provider, and then we have to paste in our API endpoint from Infura. Make sure the endpoint is specified to the Goroli testnet because we're going to be deploying our script on there. So let's copy this endpoint and then let's paste it in here, and that's basically it. Let's assign it to a variable just for consistency, and later we have to use it later anyways. So const provider equals to new ethers providers.json RPC provider, and then we put in the API endpoint over here. Let me just delete these comments. So yeah, let me minimize this window first so we can see better. We don't really need this. Alright, so this line basically helps us connect to the nodes of the blockchain, and yeah, that's basically it. That's how you connect to the Goroli testnet, and our script is connected with the testnet, with the nodes of the testnet. Now that we got a connection to the blockchain ready, it's time to actually write the part of the script where we send the transaction. So as you probably know, for every single transaction, there's a sender wallet address, and then there's a recipient wallet address, and there's obviously like a value which you're sending, and then there's like the gas. So we want to simulate exactly something like this just as a script. So first of all, let's create a variable that defines our sender account. So let's call it sender account, and it equals. Now for your sender account, just use your own account, use your own Metamask account, but remember, just use a test account. Use an account that you're not going to use for other stuff. Just create an account on Metamask that you're only going to use for this video or for any development purpose. Do not use account that you use for storing your ETH or whatever. Just absolutely use a test account, because later you have to extract your private key and you don't want to be showing off your private key. So just use a test account for this. But anyways, let's wait for Metamask to open up. So now when you open your Metamask, make sure that your wallet is on the Goroli test network. You can choose your network from this drop down menu here, but choose the Goroli test network, and then copy your wallet address off the Goroli test network. So let's copy it, and then we're the sender account, so we're the wallet address, which is going to be sending some fake ether. So this is the wallet address, and then we need to specify the address of the recipient. So let's call a new variable receiver account, and then let's actually just create a new wallet in Metamask. It's really simple. So right now I'm in my dev account, what you want to do is to click this profile picture at the top right corner, click create account, and let's just call it, just in my case, I just call it dev account 2, and I'll create. So basically what you just want to do is to create a new wallet on your Metamask, and we're going to be sending some girly ETH from the first wallet address to the second wallet address, and let's wait for it to load. Okay, so my dev account 2 has been created, and we're going to be sending some ETH from dev account 1 to dev account 2, account 1 to account 2. So copy the wallet address for the second account, and it's going to be a receiver account, so let's paste it over here. Later we're going to be sending ETH from this account to this account. And then now what you want to do is to export the private key from your sender account. So we type const private key, let's just specify that it's from the sender account just for this demonstration. And remember, because right now we are pasting in our private key over here, please remember to keep it very safe. That is also why I told you guys to create a test account for this purpose. But you should never be disclosing your private key. It's just basically like your password for your account, so don't disclose it over here. Typically you would want to place a private key in like a .env file, but because this is just a demonstration, I'm just gonna put it over here. And plus, because that's just basically a dev account, I'm just gonna delete that account after this demo. So to get your private key, let's swap back to our dev account 1, and then let's click account details, export private key, type in your Metamask password, and incorrect password. Okay, yeah. So yeah, this is my private key for my test account. I will, as I said, I'll be deleting this account in the future, so don't bother hacking. So, but anyways, I just copy this, done, and then let's paste it over here. Oops, I forgot one quotation. Alright, so let me just delete this over here. Alright, so great, we have created a sender account and a receiver account. We specified it, and then we have the private key for a sender account. Now what we have to do is to create a new Ethers wallet to process our transaction. So all we need to do is to type new Ethers.wallet, and then after that we have to pass in a private key, so the private key of the sender, which is private key sender account, and then the node provider. So in this case, this node provider function call is passed to this provider variable, so let's type provider, and let's assign this function call to a variable const wallet equals to new Ethers wallet, and then we specified our private key and our provider. So currently we have specified a sender account, and we are going to send ETH to this account, and just our private key, don't share this with anyone, and we have created a new Ethers wallet to process the transaction. Basically, as you might know, for example, when you're on Metamask and you click send, you send some ETH to one other wallet address. When you click sign, basically you're telling Metamask that basically Metamask knows your private key, and you need your private key in order to sign transactions and make them verified, make those transactions valid. So that's why you need your private key. And basically what we did in this function is that, in this line of code, is that we have a private key. We're like create a new wallet, and we have a private key so that we can sign our transaction in the future. And basically all the cryptography of the transaction is going to work under the hood. And by the way, if you want to learn more about cryptography, make sure to subscribe to our YouTube channel and check out IEEE Blockchain Hong Kong local group to learn more about cryptography, because we have some excellent professors about them. But anyways, that is the reason why we have to create this function is because we need to create a wallet that signs transactions, and we need the private key in order to verify these transactions that they're valid. So that is why we need this line, and we have basically complete most of the setup. So let's go into the actual part where we will learn how to code the transaction for our script. So now let's get into the part of the code where we'll write the actual code to sign a transaction on the blockchain. But before we get started, let's actually create a async function because we want to be able to make asynchronous calls in this case, because for Ethereum, the transactions per second can be pretty slow sometimes. So you want like the line of code to execute once the former line of code is finished executing, and we want it to instantly execute. So that's where we're gonna use the asynchronous async await pattern. So to do that, let's create a async function. So we type const main in the main function async, and then brackets here. So there we go. That's basically how to make a asynchronous call. And I forgot we have to call this function name here, main. And then right now on Ethers.js, the way to the way to send a transaction is basically just wallet dot send transaction, and it allows us to input some objects. So this bracket, and then enter. And then there are two parameters that we type in. We have to the first parameter is 2, like which wallet address 2. So we're gonna send it to the receiver account. So let's type receiver account, and then the value, which is how much ETH we're gonna send to the receiver account. So the value of ETH that we're gonna send to the receiver account is gonna be ethers.utils.parse ethers, and then we specify the amount of ether that we're gonna send. So in our case, let's just send 0.01 ETH, and that's basically it. This is basically the lines of code which allows for signing transactions on the blockchain. But because we're in an async function, let's assign it to await, and then let's also assign this to a variable. So const let's just call it transaction equals to await wallet send transaction, and we specify which account we're going to send it to and the amount of ETH that we're going to send it. And this basically allows us to send ETH. We also want to create like a some like lines of code which allows us to fetch a transaction, then wait for transactions to be mined, because that's how the blockchain works. So in order to do that, we can do await transaction, I spelled it wrong, dot wait, and then after we finish this line of code, we're gonna print out the transaction, like the details. Basically, as you see on Etherscan, you have all these like details, for example, which account to which account, how much ETH, the gas, all that stuff, the hash. So we're gonna print out the transaction. So let's do console.log transaction, and there we go. That's basically it. So basically, this line of code allows us to send some ETH to the receiver account, and then once our transaction is complete, we're gonna print out the transaction details. But this is how you send transactions from one wallet address to another wallet address using Ethers.js. But I want to do something. I want to do one more thing. I want to show the amount of ETH that the sender has before the transaction, and how much ETH the receiver has before the transaction. And I also want to do the same, but after the transaction, so we can have like a better log and we can see our transaction execute in action. So basically, we want to show the sender account balance before the transaction. So all we need to do is to type provider dot get balance. This is basically the function which allows us to get the balance of an account, and we want to get it from the sender account. Let's assign it to a weight, and then let's assign it to a variable. So let's call it const sender balance before, and equals yeah, so this line basically allows us to get the balance of a certain account on Ethereum, and then after that let's print out the balance. So console.log, and let's do some formatting over here. So let's make a new line, sender balance before $, and then ethers.utils.format ether. This is also in the documentation as well. Format ether, and then sender, print out the sender balance before. There we go. And now we want to do the same for the receiver. So let's actually copy these two lines and then paste it here. And then we want to call it receiver balance before. The receiver balance before, and then let's change it to receiver count, and then change the sender to receiver and the receiver. Yeah, so basically this is I think I spelled this wrong. Yeah, so there we go. We are going to print out the balance of these two accounts before the transaction, and we will also want to do the same for after the transaction. So let's just paste it in, just do the same thing, because these on the codes happens after the transaction is complete. So let's type sender balance after, and then get the balance of the sender account, change before to after, sender balance after. See, it's good that it's sort of reusable, so we can just easily copy paste it again. And plus Ethersjs is pretty clean. You see, this is just basically the code for our send sign transaction, and personally it's one of my favorite libraries to use for Web3 scripting. So let's copy this, let's paste it, and then let's call it receiver. I always have trouble with spelling receiver. Receiver account, and then receiver. Actually, yeah, there's supposed to be an E over here. You know what, I'm just gonna copy it. I don't want to spell this word again. Receiver account, receiver balance after. I'm sure you can do this much faster than me. I'm pretty bad at spelling. Receiver balance after, call it receiver balance after, and just lowercase this. Oh yeah, one thing, there's not supposed to be an S over here, so it's just ethers.utils.parse ether. My bad. And boom, there we have it. This is basically how to write a Ethers.js script that sends a signed transaction in on the blockchain, and we are basically done. Let me just quickly go through this entire script one more time. So over here we import Ethers.js into a project, into a file, and then we connect to the nodes on the Gorilla testnet, and then we specify the account which we're going to send ETH from, and we specify the receiver account, we specify the private key of the sender, and then we create a wallet to sign and verify this transaction. So this async function just basically handles the entire transaction. We're going to print out the sender and receiver balance before the transaction, and then we're going to send a transaction. We're going to send it to the receiver account. We're going to send 0.01 ETH to the receiver account, and then after that we're going to wait until this transaction is finished, and after we complete this transaction on the blockchain, we're going to print out this transaction and we're going to print out the balance of the sender balance and the receiver balance after the transaction. So let's test out the script to make sure it works. But before we test it, remember we are sending ETH from the sender account to the receiver account. So we have to top up the sender account with some ETH to pay the gas fee and make sure we actually have 0.01 ETH before we can make this transaction. So basically what you do right now is you want to get some Ether, but we're not going to use real money for this because we're in a test net, so we can just use something called fake Ether from like a Focket. So what we need to do is to go to Gorilla Faucet, which that just basically allows you to get free Ether so we can pay the gas. So let's type gorillafaucet.com. And then remember you have to be logged in, but anyways, after that over here, you see they will give you 0.05 Gorilla ETH per day. And then let me paste my Metamask. Actually, let me just copy this here. Let's save, then paste it, and it's gonna send me some ETH. So send me some ETH. They have a pretty cool animation. And let's make sure the 0.05 ETH is sent to me. Still processing the transaction. Let's wait for a while. And after that, you should receive some ETH. Okay, so we have received our ETH funded to our sender account. So now let's actually do the transaction. We are going to be sending 0.01 ETH from our first account to our second account. So by the end of the transaction, you should be able to see some ETH topped up into your dev account too. So let's go and run this script. It's looking pretty solid. So the way to run this script is we click terminal, we open the terminal, and then we type node, and then we have like the path towards this this file. So I'm just gonna copy the path and then paste in the path of this file, enter. There's an error, await is only await provider get balance. It's a syntax error. Let me check why. Should work. That's pretty. Oh, my bad, guys. I forgot to add a bracket over here because that's basically just the syntax of how you do an async function. So we have to do const main equals async bracket and our return. So let's run this script again, and see, they print out the sender balance before. Exactly, this is how much ETH we have, and then it prints out the balance of the receiver, which should be 0. And let's wait until this transaction is complete, and there we have it. Boom, our transaction is complete. You see, first we print out the sender receiver balance, and then we print out the transaction. As shown over here, we do console.log transaction. Let me just make the screen a little bit bigger so you can see better. And when we print out the transaction, you see they give like all this information, the hash, they see to which account, the value, and then we see our sender balance after it's deducted by 0.01. And as we see, our receiver has just received 0.01 ETH, and before we had 0, now it's 0.01. And let's make sure by going to a Metamask. Let's go to a receiver account, and there we have it. This is it, guys. This is how you send ETH. This is how you sign a transaction on the blockchain using Ethers.js. And I hope you guys enjoyed this video. I hope you guys now learned a few things about Ethers.js, and basically Ethers.js is just really powerful. And there we go, we have just harnessed one of the many things that Ethers.js can do for us. We have literally wrote a script that allows us to send a transaction on the blockchain, and well, we're printing out all the information. So I hope you guys enjoyed this video. Again, don't forget to like and subscribe to this video. If you want to see more content like this, please subscribe, and also check out our website, IEEE Blockchain Hong Kong local group, to learn more about Web3 blockchain, because we are the official YouTube channel of the local group. And be sure to stay tuned for more content like this if you enjoyed this video. Anyways, this is it guys, and good luck with your hackathons, and I'll see you in the next video. Goodbye.